This video is a continuation of the data frames notebook, and in this video we'll be discussing indexing of data frames. Data frames may be indexed similar to previous data structures we've looked at using the single and double bracket notation, as well as the subset operator, aka the $sign character. We can use these operators to get access to one or more rows and/or columns, as well as access to the individual elements themselves. Passing a single index to a data frame using the single square brackets will return the column associated with that index, including any row names if any were assigned. So here in this example, we get back the second column from df, and notice that the output here is actually a data frame, and it does include all the row names, trial 1 through trial 5. If we were to repeat this, but use the double bracket notation instead, we'll see that an unnamed vector is returned instead of the data frame that we got before. Passing a negative index with single brackets returns all columns except the one specified by the index. So the second column is omitted in this example. And do note that we cannot use double square brackets with negative indices, as it does result in an error. And of course, like we've seen in previous examples, passing an index that is out of bounds results in an error for both single and double square brackets. Also, using single square brackets, we can pass sequences of indices. So here I'll say df, and then single brackets will type 1:2, and this will return to us the first two columns of the data frame. Now, when you use sequences, you do need to make sure that the indices in the sequence actually exist. Otherwise, accessing those non-existent columns would result in an error. Masks may also be used to access columns in a data frame. Simply construct a vector of Boolean values, like so, and everywhere there's a true value, the associated column in the data frame will be included in the output. So in this example, the first two entries in our vector were true, and the third one was false. So the first two columns in the data frame df were included in the output. Yet another way to access columns are through their names or labels. And to do so, we use single square brackets and simply pass the name as a string, and you'll get back the column associated with that name. And just like the numeric indices, if we repeated this example with double brackets, we get back a vector instead of a data frame containing the same data. And also, I stated earlier that we can use the subset operator. If we use the subset operator with a column name, we actually achieve the same result as the double square brackets we have in this example. And what's nice here is that for most names, this will work with or without the quotes. If you do have spaces in your labels, then you will need to use the quotes. One final way that you can get access to columns is to use single square brackets and pass actually a comma-separated list of indices where you omit the row indices. So to do this, I write df, and then inside the square brackets, I'm going to skip the row index, type comma, and then I'm going to give it a column index. And when we run this, you see that we get a vector output of the second column. And this is actually the same output we receive with double square brackets as well as the subset operator. Also, with this format, you're not limited to single numeric indices. You may use sequences and all the other things we've seen in the previous examples. Okay, if we wish to index a row instead of a column, we're actually going to use the same comma delimited list as we had in the last example, but we're actually going to give it an index for the row, and now we're going to omit the column index. And you'll notice a difference immediately. In the output here, instead of getting back a vector of the data from the row, we actually get back a data frame, and all the types of each columns are maintained. We even get the labels of the columns, X, Y, and Z, as well as the row label, trial 4 in this case. Now, just like with columns, we can omit unwanted rows using negative indices. So for instance, I can say df, and in square brackets, I'm going to use a negative index, or actually a sequence of negative indices. So I'll say minus, and then in parentheses, I'm going to put the sequence 3:10. Say comma, and I'm going to omit the column indices since I want the entire rows. And when we run this code block, we see that we get back trial 1 and trial 2. Now, why does this work? The original data frame does not have 10 rows. Right? So when I say 3 through 10, we may expect there to be an error. And the reason this worked is that negative indices are omitting the values, or rows in this case, and not actually trying to access them. So there's no issue with trying to omit something that isn't actually there. So in this case, we're allowed to say 3:10, even though there are only 5 rows in the data frame. Now, as a last example here, we're not going to go into all the details we did with columns, but I would like to show you another way to set up a mask. For the previous example with columns, we manually constructed a vector containing true and false values, and the columns associated with the true values were included in the output. So instead of manually creating a mask for the rows, we're actually going to use the values inside the data frame to construct our mask. So let's say we only wanted to see the rows where the value in the y column was greater than 3. So to do this, we're going to write df, and then in square brackets, we're actually going to use the subset operator to specify the column y, and then write greater than 3. So we're writing df $y greater than 3 is our expression. And what this expression will do is go through each element in the column y and check whether or not it is greater than 3. The output of this is a vector of booleans, the elements of which are true if the corresponding element in y was greater than 3 and false otherwise. So we're using a Boolean mask created from the contents of our data frame to index the rows of our data frame. And then to finish this off, of course, we're going to omit the column index since we're interested in seeing entire rows. And then when we run this code block, we see that yes, indeed, the only rows that were included in the output have values in the y column that are greater than 3. Now, at this point, I'm sure you've figured out that in order to index individual elements, we must use the comma-delimited row and column indices without omitting either one. If we would like to see the element in the second column and fourth row, we of course write df and in square brackets 4, 2. And of course we can use labels here, so we can also get the same value using the label y instead of the numeric index. We can do the same thing with double square brackets. And we can even mix the row column indexing schemes above. So if I use a subset operator to get column x, I can then index the resulting vector to get an individual element, say the first element. Now, as you can tell, there are a lot of options here, and I have tried to give you several examples to consider. But if you do want more information on this, and you want to see the built-in help pages on indexing data frames, the command to do so may not be what you expect. You need to actually type help, and then in quotes, write left bracket dot data dot frame, and that will take you to the page that tells you about all the indexing schemes we've talked about here, and even give you some additional examples.